Welcome to Mr. Beck Does Your Homework. This is AP Physics Homework 2.2, question number 9, part 1 of 2. It says the velocity as a function of time of a particle is plotted as a function of time. The velocity of a particle is plotted as a function of time. The scale on the horizontal axis is 4 seconds per grid square, that's odd, and on the vertical axis 3 meters per second per grid square. Well, let's wait a second. What does that mean? Oh, this is like time times 4 seconds. So this isn't really 1, 2, 3, 4, 5, 6 on my graph. That's not seconds, but it's times 4. This is the way the system used to make randomized, randomize the answers for you guys. So if this is times 4 seconds, then this is really 4, this is 8, this is 12, this is 16, this is 20 seconds, okay? So you can just do that on yours if you want. If you had, so mine's times 4. This is velocity times 3. So this is really going in the scale of 3, 6, 9, 12 on mine, okay? So now we've got an accurate scale. All right, initially the particle is at x0 equals 59 meters. Well, what that's saying is that on a velocity time graph, I don't really know where the position is. I can find change in position, I can find other things, but I don't know the initial position, so it's telling me. So if I want to know the position at some later time, what is the position of the particle at time is 16 seconds. So I want to know where it is at this time. What I need to find out is how far it has gone plus where it started. So my answer is going to be 59 plus some amount that I've got to figure out. So just remember that it starts at 59. Now the question is, how do I figure out how far this particle has gone as it travels along for this first 16 seconds? This is where you use your knowledge that the area under a velocity time graph is the same graph equals the change in position, equals the displacement. And the reason that is because this is time and this is velocity. And since velocity is displacement over time, then I know that my displacement is going to be my velocity times my time. Well, if I'm figuring out the area of any of these boxes, I'm going to have to multiply velocity times time to get the area. So what I'm going to do is I'm going to find the area of this rectangle right here. And I'm going to find the area of this triangle right here. And when I add those together, that's going to give me the change in position of this object, which is what I'm looking for here. So what's the area of this rectangle? Well, it's length times height, so that is 16 seconds. So I've got length times height, and that's going to be, so the area of a rectangle, length times height, the length is 16 seconds, times my height of 3 meters per second. So 16 times 3, that's 48 meters. So that's the area of that rectangle. The area of the triangle is going to be 1/2 my base times my height. So that's going to be 1/2. My base, again, is on this scale 16. And my height of this one is going to be 369. So that's 16 times 9. So that's going to give you some answer there. When you add the 48 to that, it's going to give you some total. That total right there is the amount, is the change in position, is the displacement. So that's going to be the total area under the curve. So again, on a velocity time curve, the area under that whole line, the area under that line, the area formed by that triangle and that rectangle is the change in position. So 59 plus that will give you the answer that you need to plug into UTexas.